In this video, I'm testing several different 3D printed structures to see when they break. I'll be comparing triangular, circular, and hexagonal structures. I'll also include a fully solid structure to see how it performs under the same conditions. All test pieces are clamped at the same length in this bolt, so we have consistent testing conditions. Then I'll use a winch to gradually apply more and more force, while measuring the results with a force gauge. To start with, I've got a solid structure printed with 20% infill density. Up to around 15 kilos, it stays pretty stable, but at 20 kilos, you can already see a clear deformation. Just above that, it finally breaks. Next up are the special structures: the triangle, the grid, and the hexagon. Here's the hexagon first. You can see it slowly starting to deform at around 12 to 13 kilos. And by 15 kilos, it's visibly bending. The force rises briefly to about 18 kilos, but as the part deforms, it drops back down to 15. It doesn't break completely, but the deformation is quite clear. Now for the triangular structure. It holds up well until around 10 kilos, then starts to deform slightly at 13 to 15 kilos. At 20 kilos, the deformation becomes extreme. That's where it clearly reaches its limit. Let's move on to the grid structure. Here, the applied force is about 20 kilos. The deformation starts lightly, but it's noticeably weaker than with the other two. In direct comparison, the grid deforms the least. The triangle and hexagon behave very similarly. Interestingly, none of the three actually broke. They just deformed more and more until they gave way. Next, I tested a solid outer shell with a triangle, circle, or hexagon printed inside. First up, the hexagon again. I might have clamped it a bit too tightly, but it stays stable up to 15 kilos, then breaks once the load increases slightly. Now for the circular structure. Here the counterweight wasn't enough anymore. I'd already reached 25 kilos before it even started to deform. I applied some extra force manually, stepped on it, and at around 30 kilos, it finally broke. Lastly, the triangular structure. It looks stable up to around 17 or 18 kilos. At 23 kilos, small white cracks start to appear as the material begins to pull apart. And at 25 kilos, after applying the force for a bit longer, it breaks too. For comparison, I also tested a regular solid structure again, this time with 50% infill density. At around 20 kilos, it begins to deform noticeably, and the longer the force is applied, the more it bends. Finally, the theoretically strongest version, the one with 100% infill density, and also the most material. At 26 kilos, I reach the maximum force of the winch. I add a bit more force manually, and so far there's only minimal deformation. Even at 30 kilos, it's still much more stable than all the others. You can only see a few tiny white cracks starting to form. And here's the full overview of all test results. Don't forget to subscribe to the channel.